Until 2014, a unique new research project is being realized north of the European business and science metropolis of Hamburg, an international institution that will become the #1 address for top-class researchers from all over the world. Starting at the German electron synchrotron DAISY in the Hamburg district of Bahrenfeld, an almost 3.5-kilometer long tunnel system will be constructed, branching out at the site Osdorfer Born through to the town of Schenefeld in Schleswig-Holstein. The future accelerator and light generation track of the European X-ray laser. The free electron laser European XFEL will be the brightest X-ray light source generating ultra-fast light flashes on Earth. The tunnels between the underground experimental hall and the central supply station at DAISY will run in a depth of 6 to 38 meters. Another access point will be located on the site Osdorfer Born. This worldwide unique facility will enable researchers to film chemical reactions, map out atomic details of molecules, and take three-dimensional snapshots of the nano world. The X-ray laser will bring the conditions prevailing in the cosmos into the lab, a €1 billion investment in the future. The European XFEL is a joint international project with a strong connection to DAISY, which receives substantial funding from the German Research Ministry, the city of Hamburg, and the federal state of Schleswig-Holstein. The most important international partner is Russia, which contributes nearly a quarter of the total costs.
A facility of this size and complexity cannot be realized by one lab or by one country. We rather need the international collaboration of experts from various disciplines who closely collaborate to reach this one joint goal.
The European XFEL generates X-ray radiation that opens up previously unexplored dimensions. More than 100 years after Röntgen's discovery, a radiation source is now being realized in the metropolitan area of Hamburg that will provide a peak brilliance 1 billion times higher than that of the most modern X-ray sources, with results unimaginable today. The X-ray laser flashes of the European XFEL are so short that they can be used to make movies of chemical reactions. Exposure times of only a few quadrillionths of a second guarantee that nothing will be blurred.
Here in Hamburg we are constructing the European X-ray laser. This is a facility which sounds like science fiction. It's a high-speed camera which allows us to take holographic images from the motion of atoms and molecules.
The European XFEL will generate the incredible number of 30,000 flashes per second. Until now, researchers from all over the world could only dream of such experimental possibilities.
And I think it's very important now that a major breakthrough is taking place in this field, that Europe is there, and is there since the very beginning. So we think it's very important that such a project is realized not only in the United States and in Japan, but also in Europe.
The European X-ray laser will attract scientists and students from many different fields of study to northern Germany. And the unique opportunities it offers will inspire especially the new generation of scientists to come up with completely novel ideas. The performance of the European XFEL will benefit a wide range of natural sciences, from physics and chemistry to materials science, geological research, and the life sciences. It will also open up new perspectives for industrial users, for example, for the development of new materials in the nano world, with dimensions measured in billionths of a meter.
The European XFEL will be fantastic for scientists. With its enormous intensity, we can do experiments impossible to even dream about today. But more exciting, we will break new frontiers in experimental research.
In the experimental hall of the European XFEL, researchers will be able to explore the rules of the game of life in the greatest detail. The X-ray laser will enable them to follow the motion of biomolecules and the progress of chemical reactions in real time, which will allow them to better understand atomic processes. This will also help improve everyday life, for instance, through more effective medicines or more environmentally sound exhaust filters and catalytic converters, a worldwide challenge.
Imagine a football game where you receive a photograph right before kickoff and another one after the game is over, together with the final score. This is how we treat most of chemistry and biology today. You know the outcome, but you do not know how or why the result was achieved. The European XFEL will allow us to deliver a motion picture of the entire football game, or better, of the entire molecular reaction. From this knowledge, we hope to derive information about how to improve functional devices such as solar energy converters or even pharmaceutical products.
The start of the construction work in Schenefeld and Hamburg in January 2009 marked the beginning of one of the greatest scientific challenges of the century. The European XFEL facility will seek out the answers for the life of tomorrow. Starting in 2015, the international research community and DAISY will meet that challenge. Welcome to the light of the future.